All right, Algebra 2, here we go again. We're done with our roller coaster activity, building them roller coasters. Hopefully you guys got something out of that, some good stuff there. Now we're digging back into the book, getting back to our curriculum here. We're in 3.1, Chapter 3, first section, Graphing Systems of Equations. A new look here, but it's the same stuff we've been doing. We're still graphing lines, y equals mx plus b. Essential question, what does a solution of systems of linear equations represents? Remember I talked about at the beginning when we were talking about graphing lines, all the points on that line are solutions for your equation. You can plug into that x and y and you're going to get a true statement out of that. So now we're looking for the point, if there is one, that solves two equations at the same time. Okay? How do we go about doing that? First thing, get the equations into the y equals mx plus b. Is that the only way to graph a line? No. But it's the way that I told you. I'm going to try to stick with one way so you don't get confused, and we'll work it that way. We're all familiar with this, slope and y-intercept. Plot the y-intercept, move the slope, there's your line. The difference here is you got two equations, and you'll see that in my next example. You're just going to graph both lines on the same graph, same xy coordinate. Three types of solutions here, okay? We're looking at three different types, and we've talked about these as we've solved problems so far. The first thing, our two lines intersect. What does that mean? That point of intersection, that xy, I can plug that point into both equations and it'll be true. They'll both be true. Okay, not one, but both. If the lines are parallel, that means there is no point of intersection. That means there's no solution. Remember we solved problems and we get something like 5 equals 7. It can't. That means there's no solution. Well, that's what it means graphically, parallel lines. And then if you get the same line, that's one line on top of the other, okay, then that means infinite solutions because there's infinite number of points in a line. You learned that in geometry last year. And so there's infinite solutions because they're both the same line. So you can take any point off there and make it work. So what does it look like in a problem? Okay, you're going to get something like this. 3x plus 2y equals 8 and x plus 4y equals 12. If they're in the y equals already, you're good. Okay, don't mess with it, just graph it. But if it's like in standard form like this one, I'll take the first one here, negative 3x plus 2y equals 8, and I'm going to solve for y. Okay, I'm going to add my 3x because it's negative there. Let's keep it in the y equals mx plus b form. Bring the negative here with your 3. That's a positive 8, so add it. Then divide everything through by 2. So I get y equals negative 3 halves x plus 4. Okay? Second equation over here, I'll do it in red. I'm going to subtract the x. 4y equals negative x. That's a negative 12, so I'll put minus 12. Divide out the 4. And I get y equal to negative 1/4 x minus 3. 4 goes into 12 3 times. So there's my two equations. Now let's graph. There's your y. There's your x. Now I've got graph paper in here. If you have graph paper, you're going to want to use it. Because when you do it by hand, and you'll see here, it's a little tougher sometimes to figure out that exact point. But if you got graph paper and you use a straight edge, piece of cake. Okay, so I'm going to take my blue equation, the first one. My y-intercept is 4. My slope is negative 3 halves. That's down 3 over 2. There's that equation. Okay, nothing new. Negative 3 is my y-intercept. Slope is negative 1/4. Down 1 over 4. So down here, if I extend that down, that's all you got to do. If your line's not big enough, extend it. Okay? Right down here is where my intersection is going to be. And that point, did I graph that first one wrong? No, we're good. Okay? So somewhere right down in here is our intersection. 1, 2, 3, 4, 5, 6. It's about 7. When I go down 4, 3, 4, 5, 6, 7, it's going to be about somewhere in the neighborhood there. Now what do you do when you're doing it by hand? How do I know if that's the right answer? Plug it back in. Okay? and you can figure them both out, and they should both be equal, okay? Oh, that's what I did right here. And nobody said anything either, and I made a big mistake there. Come on, guys, speak up. I graphed that one wrong. So we want to go up 3 and over 2. So now our intersection's over here. I can't believe you guys just let me sit there and make that mistake. So what are we looking at here? -4, -2. Okay, and you can check it. Does that work? I'm going to get, if I took this equation here, -2 is my y. 4 times the 3/2, that's -4, plus 4. I get -2 equal to, that's going to be -12 over 2, so that's -6 plus 4. That checks. -2 equals -2. And if I put in the 4 here and the -2, I get -2 equal to a +1 minus 3. -2 equals -2, so that checks. Okay? So when you graph at one intersection point, you'll see that that solves both of them. If the lines are parallel, and you'll know that too, if I looked here and saw the two slopes are equal, I know I'm parallel. Okay? And if my y-intercepts are different, they'll be parallel, no solution. If the two equations are exactly the same, then I know I've got the same line and it's infinite solutions. Okay? So, there you go right there. Nothing new, graphing lines. Looking for the intersection. If there is one, that's the solution. When you get back into class here tomorrow, we'll put all this together and then look at some application of it too. All right, you guys have a good one. We'll see you then. Thanks.